All right, so here we are. This is part 3 of section 4.1, and we're going to take a look at finding those values that we were talking about a moment ago. But first we have to do some definitions. First off, definition of a critical number. Let f be defined at c if f prime of c is equal to 0, or if f is not differentiable at c, then c is a critical number of the function f. So these things we were finding up here earlier. This point right here, we would call that a critical number. We would say that x equals 3 is a critical number for the function 9 times the quantity x squared minus 3 divided by x cubed, because the value of the derivative is 0. We would say that 0 is a critical number of the absolute value function because the derivative is not defined at 0. Okay. For this one over here, f of x equals sine x, we would say that x equals pi over 2 or x equals 3 pi over 2. These are both critical numbers for the function sine x because the derivative is equal to 0 there. So basically what we're doing is we're just giving a name to something that we need to find in order to find those maxes and mins. That fancy name we're giving it is a critical number. A critical number of a function is a value, an x value, where the derivative is equal to 0, the first derivative is equal to 0, or where the function is not differentiable. Okay? So equal to 0 or not differentiable, we call that a critical number. And then Theorem 4.2 says that relative extrema only occur at critical numbers. Now be careful here. Right? This says that if you have a max or a min at c, then c is a critical number. This does not say that if c is a critical number, it means you're going to have a max or a min there. It says if you got a max or a min, then it is a critical number. Right? So if you've studied logic at all, if p, then q is not the same as if q, then p. Right? These are not the same statements. So if you've got maxes or mins, then you're looking at critical numbers. Doesn't mean the same thing as if you're looking at critical numbers, you got maxes and mins. Okay? All right, so here's what we're going to do. These are our directions, our guidelines for finding extrema on a closed interval. Okay? To find the extrema of a continuous function. Okay, so I'm just going to stop right there and remind us that we have to be looking at a continuous function. If you have a function that has breaks in it, if it has jumps or gaps or holes, if it's not continuous, then these steps don't work because your function is messed up in some way. You have to use a different approach to find those maxes and mins. So if your function is continuous on a closed interval, so from somewhere to somewhere, endpoints included. Okay, so we're talking about things like on the interval 3 to 5, something like that, where it has to start somewhere, stop somewhere, and contain all the points in between. Here are the steps that we're going to do. We are first going to find all the critical numbers of f on that interval. Now, they just list this as one step, but what's really involved here is this really means we need to find f prime of x, and then we need to set f prime of x equal to 0, or find where f prime of x does not exist. So that's a lot right there, okay? Then once we've found all those critical numbers, we will then evaluate the original function f at each of those critical numbers. Then we'll evaluate f at each endpoint of a and b, so that means find f of a and also find f of b. And then we get to look at all those numbers, figure out which one is the biggest y value, that's going to be your greatest or your maximum, and then find out which one of those is the smallest, your minimum value. Okay, so those are our steps. It looks simple because it's only 4, but really there's a lot in here. Okay? This is our first example, and so our job is to find the extrema of this function on that interval. So here we go. Let's do everything we need to do to find the extrema of this function on that interval. Okay, so step 1, find the critical numbers. Step 1, critical numbers. Okay, and because I haven't quite memorized it yet, I'll make a note to myself. That's when f prime is equal to 0, or when f prime does not exist. But to do either of those two, I first need to find f prime. So what is f prime of x? That's going to be 12x cubed minus 12x squared. Okay. Now, me personally, I always do the does not exist first. That way I don't forget about them. So are there any values of x for which 12x cubed minus 12x squared does not exist? Okay. What does that mean, that it wouldn't exist? Well, it means that I'm looking for those issues that would cause it to not be evaluatable. I'm looking for a division by 0. I'm looking for a root of a negative number. I'm looking for trig of some value that would give me an asymptote. I'm looking for those sorts of things. And given that my derivative is 12x cubed minus 12x squared, I don't see any of those things. So I believe that there are no values for which that derivative will not exist. So there are none of those. Now I'll look at the other kind of critical values. That is, when is f prime of x equal to 0? Okay, so when is our 12x cubed minus 12x squared equal to 0? So I'm just literally going to do that algebra. Let's see, I think that left side will factor. I know I can take a 12x squared out, so I have 12x squared times x minus 1 is equal to 0. Okay. If 12x squared is 0, that means that x would be 0. And if x minus 1 is 0, that would mean that x would be equal to 1. So I have two critical values. So now that we've found the critical numbers, what's step 2? Evaluate the function at the critical numbers. So now that we're done with step 1, we'll do step 2. Step 2, we need to find f of 0 and f of 1. Okay. Now, I want to point out something. This is the first example where we're consistently going to be working, and further examples where we're consistently going to be working with both a function f and its derivative in the same problem. So please be careful. Please make sure you're labeling things. Please make sure you know what function you're working with and what function you should be working with, because there have been many examples where students have, where I've had my students working these problems and they're putting the value into the derivative when we should be evaluating the function, or evaluating the function when we should be evaluating the derivative. So please be careful. You'll notice that I label everything as I'm working with it, and that's because I want to keep things straight. Okay. All right, so f is 0. So plugging in a 0, we get 3 times 0 to the 4th minus 4 times 0 cubed, which is equal to 0. And then f of 1, we're going to have 3 times 1 to the 4th minus 4 times 1 cubed, which is equal to, let's see, that's going to be 3 minus 4, negative 1. Okay, so now we're done with step 2. Now we do step 3, evaluate the function at each endpoint. Okay, so we move on to step 3, evaluate the function at the endpoints of the interval. So that means we need to find f of negative 1 and f of 2. Right? F of negative 1 is going to be 3 times negative 1 to the 4th minus 4 times negative 1 cubed, which I believe is 7. Right? Negative 1 to the 4th is positive 1, so 3 times 1 is 3. Negative 1 cubed is negative 1 times negative 4 is positive 4. 3 plus 4 is 7. And now we have f of 2, which is 3 times 2 to the 4th minus 4 times 2 to the 3rd. 3 times 2 to the 4th. 2 to the 4th is what? 16. 3 times 16 is 48. 2 cubed is 8. 4 times 8 is 32, so minus 32. 48 less 32 is what? Let's see. 48 less 32 is 10 and 6, 16. Okay. I'm done with step 3. Now we go to step 4. The least of these values is the minimum. The greatest is the maximum. Okay. So now that we're on a closed interval, which one of these is the smallest? I believe that one's the smallest. And then which one will be the biggest? That one will be the biggest. So it looks like we have our minimum, our absolute minimum at the point 1, negative 1, and we have our absolute maximum at the point 2, 16. Now, given that I'm brand new at this and I'm not certain I'm doing things right, what I'm going to do is I'm going to go ahead and graph this thing to make sure that I'm actually seeing what I should be seeing. So I come over here to Desmos. And we'll go ahead and graph this thing. So we're graphing the function f of x equals 3x raised to the 4th minus 4x raised to the 3rd. But I only want to see part of it, so I'm going to add on here some squirrely braces. I want to see the part from -1 is less than or equal to x is less than or equal to 2. So that's the only part I want to see. And it looks like we got a low point right there. Zoom this in. So we got a low point right there at 1, -1, and it looks like the endpoint of this thing, which Desmos doesn't like very well. Okay? But we could plot that endpoint. That endpoint is, what is that going to be? That's going to be 2, comma f of 2. And then we can see that it is 0.216. So we got a low point and a high point, an absolute minimum and an absolute maximum. I feel pretty good about this. I found the extrema. Right? Since it is a closed interval, I'm looking for the absolute max and the absolute min. I like this. Right? This brings us to the end of section, what was this, 4.1. Right? Next video will be section 4.2.